Think about your daily morning. You wake up to the sound of an alarm and probably hit the snooze button a couple of times. It's not until the display shows you're late that you finally rush out of bed and into the cold bathroom floor. You flip a switch and bam! The bright light hits your eyes. You take a warm shower and brush your teeth with an electric toothbrush. It's breakfast time. Put the bread in the toaster, press a button, and anxiously wait for the toast to jump out. You touch a few other buttons and make delicious coffee. You get thirsty and you open the fridge. As the door opens, a light turns on and you're greeted with a chill. As you're eating and watching your favorite morning show, you're also catching up on your texts. Think about how many interactions you have with the electric world before you even step foot outside. Alarms, lights, water heaters, electric toothbrushes, toasters, coffee makers, refrigerators, TVs, and phones are all just a few examples of circuits that you interact with every day. It is the circuit inside each and every one of those machines that makes your routine what it is. But a circuit doesn't have to be a complex computer or a rocket. In fact, a simple battery connected to a light bulb is a circuit. Any two or more components connected electrically create a circuit. There are two main categories that most electric components fall under. The first one is those elements that generate energy, such as the battery in our example. The second category consists of components that consume energy like the light bulb. There's a third category of components that don't generate or consume power, rather act as a storage unit. We'll talk about storage components later on. For now, let's keep it simple. There are two fundamental parameters to describe any circuit: voltage and current. No matter how big or small, every circuit is designed to satisfy a specific voltage and current. Also, every circuit can be fully analyzed by identifying voltages and currents within all its parts. But what is voltage? You can think of voltage as the difference in the amount of energy between 2 points in a circuit. Just like different rooms in your house may be at different temperatures, different parts of a circuit may have different amounts of energy. What makes voltage tricky is that it's relative. You cannot define voltage as a single point without establishing a reference. To understand this concept, consider a circuit with two batteries and two light bulbs connected by a wire. Point A has some energy due to battery 1. Similarly, point B has a different amount of energy due to battery 2. Since batteries are part of the energy generating category, we know that point B has more energy than point A, and point A has more energy than point D. Let's show this energy difference with a bucket at point B that has more content than a bucket at point A. Every time we add a battery, we reach points of higher energy in the circuit. Now point C is after an energy consuming component, the light bulb, so the energy at this point is lower than the energy at point B. Following the same logic, the energy at point D is lower than the energy at point C. Every time we pass through an energy-consuming component, we reach points of lower energy in the circuit. We don't know if the energy at point C is greater than at point A because we don't know if the energy generated by battery 2 is greater or smaller than the energy consumed by the first light bulb. It's even possible that the energy at point C is exactly the same as that energy at point A. We will talk a lot more about this concept in later videos, but for now it is important to recognize that each point on the circuit may have different amounts of energy depending on the type of components present. A bit of vocabulary here to impress your friends. Each point on the circuit is called a node. From now on, we'll refer to points as nodes. Now that we know that each node has an associated amount of energy, we are ready to look at the voltage between two nodes. Just like your weight is measured in pounds or kilograms, voltage is measured in units of volts. Don't forget that voltage is the difference in energy between two nodes. What is the voltage at node A is a question that cannot be answered unless the second node, also known as the reference node, is specified. For instance, the voltage from A to D is the difference in energy between points A and D. In this circuit, this voltage is equal to the voltage rating of battery 1. If battery 1 is a 2-volt battery, then the voltage from A to D is 2 volts. We denote the voltage from point A to D as VAD, so we know that point A is 2 volts above point D, but what is the voltage VDA? Note that we changed the order of nodes in this question, and since point A is 2 volts above point D, it is also true that point D is 2 volts below point A. Therefore, voltage from point D to A, or VDA, is negative 2 volts. Since I sense that you're not fully convinced about the relative property of voltage, let's analyze node B. Let's assume that battery 2 is rated at 5 volts, so the voltage from B to A, VBA, is 5 volts. But what is the voltage from B to D? Well, if B is 5 volts above A and A is 2 volts above D, then it's clear that B is 7 volts above D, making VBD 7 volts. If we ask you what the voltage is at B, but we don't tell you the second point, how can you answer? The voltage at B is 7 volts when compared to D, but only 5 volts when compared to A. So there, voltage must always be given relative to a reference. Now we're ready to look at current. Current is measured in amperes, or simply amps. Current in a circuit requires something to flow from one point to the next. Without any movement, current cannot exist. In a circuit, we have electrons flowing. Electrons always flow from points of low to high. In general, electrons travel in random directions, but the group of electrons always flows in a single direction. In our examples, electrons will travel from node D to C to B and to A. We said that electrons move from points of low to high voltage. By convention, the direction of positive currents is opposite to the direction of electron flow. So the positive direction of current is always from nodes of high voltage to nodes of lower voltage, although current can be specified in any direction. Suppose the current going from B to C is 1 amp. Then it's also true that the current going from C to B is negative 1 amp. Just like the voltage can be positive or negative based on the reference node, current can change polarity based on the chosen direction for analysis. Zooming into our circuit, electrons need a wire to flow, but a wire alone is insufficient. In order to have a current flowing, a closed loop must exist. In our example, there is a closed loop that goes around the 2 batteries and the 2 light bulbs. But if any node in the circuit is not connected, the electrons cannot flow and no current is present. When a node is not connected to anything, it is called an open circuit. If we do not have a closed loop, no current can flow and the light bulbs turn off. This is the use of switches in a circuit. Every time the switch is flipped, the current opens and the light turns off. When the switch is flipped back, the circuit node connects, electrons start flowing, and the light turns on. When the switch closes the circuit, it connects 2 wires together, creating the necessary loop for current to flow. Nodes in an open circuit can have different energy levels, therefore a voltage. But no current can flow in an open circuit. Electrons just don't have a path. In our example, a voltage VED may be greater than 0 volts, but no current flows from E to D. In fact, no current flows anywhere on this circuit because we do not have a closed loop. Circuits are part of our everyday life. Circuit complexity ranges from simple light bulbs and batteries to supercomputers and space shuttles. A voltage is an energy difference between 2 nodes in a circuit. A current is due to a flow of electrons. By convention, positive current flows opposite to the direction of electrons. An open circuit may have a voltage greater than 0, but the current is 0 amps.